Hi guys, today we will solve another proton NMR and C13 NMR spectra for the cyclopentanone. You may see here. This is the C13 NMR spectrum of cyclopentanone and this is the proton NMR spectrum of the cyclopentanone. The chemical formula that we will get for this compound is from the mass spectrum, but we will not solve the mass spectrum, we will only solve the proton NMR spectrum. But yes, we can solve the IR spectrum because it will not take much time. So let's see from here. This is the cyclopentanone structure and this is the proton NMR for this. So we will start from the IR spectrum of cyclopentanone. As you may see here, 1738 region. This region is due to the carbonyl groups that are present in our compound and mostly the range in the 1700 to 1750. This comes due to the ketonic group that is present in our compound. So now from the IR spectrum, we know that ketone group is present in our compound. Okay. As you may see here, this is the mass spectrum. As the NMR spectrum tells us about the structure of the compound, so we will take this information and we will solve our NMR spectrum from this information to get our structure. Okay, this is the C5H8O. This is your molecular formula. First of all, we will solve the C13 NMR spectrum for this compound. As you may see here, this is the depth. Two C13 NMR spectrum are given here. First is depth and the second is proton decoupled spectrum. Depth always tells you about whether the CH group, CH3 group or the CH group is present in your compound. If the CH3 and the CH groups are present in your compound, then depth will give you the two peaks for this, one for the CH3 and one for the CH, and this will be in the upward direction as the line here indicating this arrow is in the upward direction. And if the CH2 group is present in your compound, this will give you the line in the downward direction. So now if you see here in the depth, only the two peaks are present, but these are in the downward direction. So the first interpretation that we will get from the C13 NMR spectrum is that CH2 group is present here for this peak, and for this peak also the CH2 groups is present. And the other thing that we are getting from this structure is that both the CH3 group and the CH is absent in your compound. Okay. Now this is confirmed that only the CH2 group is present, right? And now for the proton decoupled spectrum. Proton decoupled spectrum is that spectrum that will give you the number of the different carbons that are present in your compound. As you may see here, 1, 2, and 3. Three signals are present here, so it means that three different types of the carbons are present in your compound. This peak is the same as the peak that is in the depth, so it means that this represents the CH2 group. Similarly, this peak is also gives you the information that CH2 group is present because in the depth the same peak is in the downward direction, so it means that this two peak represents the carbon atoms that is attached with the two hydrogen atoms. So now come here. This peak, this is very small peak. So this tells you that there is also another carbon atom present. But in the depth, this peak is not present. So it means the carbon atom that is present here is not attached with any hydrogen. It is just a single carbon. But it may be attached with any other group. It may be attached with any other group to satisfy its balance. But it is sure that hydrogen is not attached with this carbon. Okay. Now the information that we are getting from the proton decoupled spectrum is that three kinds of the carbons are present and two of them are CH2 group. In comparison with the depth, it tells you that 2 CH2 group is present. If you see here the chemical shift value, it is almost 30 ppm value and 38 ppm value. This ppm value also indicate that CH2 group is present. So this is information that you are getting from the C13 NMR spectrum. Okay. Proton NMR spectrum. As you may see here, that you are getting the two peaks, one peak here and one peak here. If you see the chemical shift value, then you will see that it is almost 1.9 ppm value and 2.1 ppm. These are very close to each other. So now if you see here, here is the expansion of these two peaks. If you see here, some kind of the triplet is present here, and here is also the so it means the hydrogen that is present here is attached with the two more carbons in its neighboring. It means it by and we get this information by following the n plus 1. N plus 1 rule tells you here you may see the n tells you the number of the hydrogen that are present in the neighboring, and the 1 is the hydrogen that we are considering. If you see here, n plus 1 rule tells you that you are getting the triplet. So I am writing here the triplet. If you want to know the number of the neighboring atoms, so what you will do? Simply, you will do 3 minus 1. So the neighboring hydrogens that are present in respective to the hydrogen that you are considering are 2. So it means that in its neighbor, 2 hydrogens are present, and similarly, this peak is also giving you the triplet. So it means is in its neighboring also the 2 hydrogens are present. So here, 2 hydrogens are present, it means the CH2. And similarly, this is our respective CH. And now, how many hydrogens are present in this peak area? This information we will obtain from the integration value. If you solve this scale, you will get that 4 hydrogens are present here. And similarly, the 4 hydrogens are present here. In the C13 NMR spectrum, you have found that only 2 types of the carbons are present. First type of the carbon is attached with these 2 hydrogen atom, and the other kind of the carbon is that which is not attached with any hydrogen. So it means here may be possible that 2CH2 group is giving you this chemical shift value, and the 2CH2 group is giving you this chemical shift value. Because we are here studying the proton NMR spectrum, it means the protons are must. So here it may be possible that this is the CH2 group and the CH2 group is in its neighbor. Similarly, this peak also gives you the information that this is the CH2 group is present here, and that is attached with another CH2 group. That information and this information we get it from the n plus 1. So now we have so now if you see here, the 4 hydrogen is present, so it means that the 2 CH2 groups are here, and similarly the 4 hydrogens are present in this peak area, so it means the 2 CH2 groups are here. If you remember the chemical formula, that was C5H8 and O, and this is the oxygen. So now if our carbon is not attached with any hydrogen, so it means that it is attached with the oxygen. So now it is clear that we have a carbonyl, and this information we also obtained from the IR spectrum, as you may see here. So now back to our proton NMR spectrum, you will now see that you have the 4 CH2 groups and 1 carbonyl. Then how you will arrange this molecular formula to get a structure? It is very simple. CH2 groups are always attached with each other to satisfy their valency. As you may see, these CH2 groups now, this carbon's valency is satisfied. This carbon has also satisfied valency. Now the problem is that these 2 carbons have one valency is less. So as you know that there is also another carbon. Now these 4 carbons have this satisfied valency. These 4 carbons have the satisfied valency, but this carbon is no valency is not satisfied. That is too less. So if we attach this with the oxygen atom, now if you see all the 5 carbon atoms have this satisfied valency. So it means that the carbon, if we count the number of the carbons are 1, 2, 3, 4, and 5. And in the molecular formula, we have the 5 carbons. Similarly, if we count the number of the hydrogens 2, 4, 6, and 10. 2, 4, 6, and 8. And the number of the hydrogen in our molecular formula is 8. And the number of oxygen is 1. And here the number of oxygen is 1. So now our molecular formula is satisfied with our structural formula. And the NMR is used to get the structure. So the structure that we are getting from the NMR is the cyclopentanone. As you may see here, this is the cyclopentanone. And if you like my videos, then please subscribe my channel as me. And if you like my videos, then please share my videos and subscribe my channels for more videos like